Good morning, good afternoon, and good evening, wherever you are joining us for Intelligent Automation in Oil and Gas. My name is Nicole Bamford, and I'm the moderator for today's session. On behalf of Leslie, Angeliki, Quinn, Candace, and I, we thank you for joining us for day one of the event. This presentation, Implications of Time Series Data for Data-Driven Process Manufacturing, will be given by Tim Hall, VP of Products at InfluxData, and Kelly Kohlleffel, VP of Sales Marketing and Alliances at Hashmap. And their presentation promises to be well worth a listen. Before we get started, here are some quick administrative points. During the webinar, if you have questions for the presenters, please submit them in the Q&A box on your screen, and these will be answered during the question session after the presentation. Likewise, for any technical issues, please write them into the Q&A section and we'll get to them right away. The widgets on your screen can be resized and dragged around for your viewing preferences. We encourage you to visit the Resource Center on your screen for additional content and resources we and our sponsors have provided for you. So make sure you're sitting comfortably, and I'll now hand it over to Tim so we can begin.
Thanks, Nicole. Hello, everyone. Just quick introductions. I'm Tim Hall, and as Nicole mentioned, I'm the head of products for InfluxData. And we'll talk a little bit about, and I'm super jazzed to be reunited with my former colleague, Kelly. Kelly and I worked together a few years ago, and when I was invited to speak to the oil and gas industry, I thought, who do I know on the planet who has spent time with oil and gas more so than I have, who I'd love to have as a co-presenter and has continued to sort of deepen his experiences with this industry group. And so, Kelly, welcome. I'm super glad to be reunited with you today.
Yeah, Tim, thank you. Really appreciate it. And thanks for everyone for attending the session. Had a great time working with you in a previous life. I'm with Hashmap today. Just a quick background. We're a consulting services firm. We've spent, right about a decade working with clients to build better data products and data solutions that focus on business outcomes. So typically where we're called in is to assist in challenging data pipeline problems. So how do I acquire it? How do I transform it? How do I persist it? How do I consume it? And today, like Tim mentioned, we're going to share some experiences, our perspectives, our thoughts around time series data. And looking forward to it. So Tim, let's get it kicked off. What is time series data? What's your perspective on that?
Well, Kelly, I'm glad you asked. And it's particularly in the process manufacturing industry, of which oil and gas is one. Time series data, we'll take a step back. It comes in two forms. There's a regular series, which is, you can kind of think of it as taking a sample. So the data is always available, but how frequently do you want to pull that sample and evaluate it is one way to think about it. And typically you're going to be plotting that, that sample on a graph where one of those axes will always be time. And then the other way to think about time series data is there's also the irregular series, which is you don't know when in time it's going to occur. It just happens. And when it does, you want to capture the particular time that it does. And so typically these are events, start time, stop time, those sorts of things. So where are we in the world of time series, and why does this matter? We are currently in the age of instrumentation. So on the one hand, you have we've started to deploy sensors across the physical world, and so this is affectionately known as IoT, or you may hear it called IIoT, the Industrial Internet of Things, or just the Internet of Things. And of course, it's happening in the virtual world with the convergence of development and operations, the world of DevOps, where we're instrumenting more of the IT stack. If you're a software as a service provider or providing any software-based solution today, you want to instrument pretty deeply what's going on. And I think, as Kelly mentioned, we're focused on driving business outcomes, and not just for the sake of knowing. And so obviously getting that information and effectively using it is key. And so InfluxData, we are the creators of InfluxDB. It's a purpose-built platform for all types of metrics and event workloads. And as Kelly mentioned, acquisition of that data sometimes is a challenge. Getting it clean and in a processable form is key. being able to analyze that data at scale and speed and then take actions on that data is what we're focused on delivering for our customers. And we are uniquely focused on developers and builders. And so one of the key tenets of our company is focused on developer happiness and a concept we call time to awesome. Time to awesome is really about developers being able to go out and solve problems very, very quickly without having to drag in a ton of additional dependencies and infrastructure and things that essentially get in your way of driving those business outcomes that Kelly mentioned. And in particular, we built the platform to run reliably in a lights-out environment, meaning you can set it up and run based on a certain set of resources and parameters and have it run effectively and efficiently without having to have an IT staff or a DBA or others look over its shoulder every second of every day. And so that's particularly important in operational technologies and environments in which many of you may be working. And just to give a quick sample of some of our customers across those two spectrums, the IoT monitoring spectrum and that sort of software or DevOps monitoring spectrum, a few named software providers and folks in the energy space and other IoT locations. And we're going to go customer examples at the end that are specific to oil and gas and manufacturing overall to dig a little bit deeper. Because I know sometimes when we talk about this, people will say, well, this is science fiction. Tim, Kelly, you guys are like not working in the real world. And so I do want to provide some examples of where people are today and how they're taking advantage of this technology. Now, one last little piece from an offerings perspective and what you can tap into if you're interested in Influx and using this as a time series platform for your own solutions. We do offer the platform as a single node open source binary that has all the features and capabilities. And typically this is used for the development environment and also for deployment at the edge. And there's a common API across all of the offerings. So essentially you can write to that API and move your application again from the open source to cloud or enterprise. The two commercial offerings are both cloud and enterprise. Our cloud offering is available on all three major cloud service providers, including AWS, Google Cloud, and Azure, and integrated into the AWS and Google marketplaces as well. So if you're already consuming services from those folks, you can get us dropped right onto your bill. And then there's a managed by you offering where we sell you the software subscription. Again, common API across, write to that API once and deploy across these different environments at will. And so with that, Kelly, I'd love to get your perspective on where you see time series with your clients and how that's being adopted in the process manufacturing industry.
Yeah, I appreciate it, Tim. You had talked about earlier that this wide world of time series, and while you were saying that, I was thinking one of our architects recently said that the world is time series. I mean, when you think about it, pretty much everything we do is captured, is processed, is analyzed in time. It's, our financial transactions. It's your favorite website, your favorite social app, your favorite utility provider, our cars, our trucks, all of that stuff that is happening is stored in time order. The challenge is that, some of it's slow, some of it's relatively fast. You look at, a mountain, look at Mount Everest, for instance. I mean, 2.4 inches per year versus, if you guys have seen that infographic, what happens in an internet minute, they have it updated for 2020, and you get 4.1 Google searches, 4.1 million Google searches, 19 million texts. I mean, it's just massive amounts of information that can flow in the course of just a second. But whether it's slow or fast, it's all happening in time. And I think you've got this disparity. You look at oil and gas, for instance, just in the drilling domain with downhole telemetry systems, there's a pretty wide range of data collection times. I might look at mud pulse telemetry or acoustic telemetry that's 5 minutes, 6 minutes, 7 minutes if I'm using those. But if I go all the way to wired pipe, that's almost immediate, right? So I've got this range even in a relatively short window. And I think that when we look at time series data from a Hashmap perspective, one of the things that we look at is how do we work backwards from who's consuming the data? What does the use case require? Is it immediate? Is it 5 or 10-minute latency? Are there use cases potentially today where, okay, next day or even further out, when I'm combining those time series data sets with other data sets of context and enrichment, makes sense as well. And I think when I look back maybe 5 years ago, Tim, when you and I were working together, it was all about capturing and storing everything. Let's just grab it all. Today, like you talked about, these outcomes, how can we do something impactful with the data as fast as possible, but very impactful with the data, and consume it in a way that really delivers true business value? And I think when you look at time series data, sometimes it's, we can all be relatively careful of avoiding going down that path where maybe we don't have to capture every single point. Maybe we do. Again, use case based. What level of quality, what level of latency? And however we're addressing those dimensions, have the use cases to back it up. So, I mean, that's how we're thinking about it. I think when we go into clients or we get called in, so time series data, what is it? Some of the value. What about, Tim, diving into a little bit time series data in the context specifically of process manufacturing?
Yeah. And you mentioned a couple examples that are great. And so taking this a step forward with that as sort of the backdrop, this term Industry 4.0 got coined back in 2012. And I know, again, like people are like, yeah, it's a buzzword. Tim, Kelly, you guys are not working in the real world. This is happening, right? And what does this mean? If you're not familiar with the term, Industry 4.0 is representative of the fourth revolution that's occurring in manufacturing at large, right? Where the first industrial revolution was really focused on mechanization through water and steam power, and then the shift to mass production and assembly lines using that electricity in the second. The fourth industrial revolution really takes what was started in the third, which was adoption of computers and automation, and enhancing that into smart and autonomous systems that are fundamentally fueled by data and machine learning. And so the big difference between Industry 4.0 versus 3 is that while in the former, computers were sort of introduced to enhance existing processes, the current wave of Industry 4.0 really seeks to reinvent the entire process around the power of data. And so you see lots of companies starting on this journey through instrumentation and observability, and then attempting to learn based on that data. And I think, Kelly, when you and I worked together previously, the learning was happening on all of that historical data set. And the idea now is, how can we act in time as the data arrives in the appropriate amount of time based on the type of insight or the type of action that you need to take. Sometimes those historical insights are valuable and they can be used to drive certain activities, but those don't need to happen in real time. Others do. And so related to that, within the context of Industry 4.0, we have these sort of two traditional setups within the process manufacturing space. You have your operational technologies and your information technologies, so OT and IT. And I'm sure everyone on the webcast is familiar with these two terms. But Industry 4.0 really doing a soup to nuts reassessment of the entire manufacturing process, so that automation in form of that cyber and physical system and data exchange through the sensors that are deployed, enabling this IoT world, is really at the core of the manufacturing plant rather than an afterthought. And traditionally, because we've been split into these two worlds, where OT has been focused on sensors and software that monitor the control and manufacturing process, and IT is provided as a sort of separate function to focus on data processing and analytics, the way of really looking at this from an Industry 4.0 perspective is that we need to converge these two things. They need to sit much, much more closely together. Because it necessitates the reinvention of the entire manufacturing process with a backplane of a data architecture that starts with OT and traverses all the way to IT. And what we should be doing is looking at what's the appropriate entire environment in terms of what is needed for operationalization, and then what is needed upstream to do things like predictive maintenance schedules and those sorts of things. And so many of you then may cry, well, I've got a data historian that already handles all of this kind of data. Why isn't that sufficient? It is true that the cornerstone of advanced manufacturing is a central control system, whether it's process or physical manufacturing. And so time is the critical element in the operation of all of these things. And what we're seeing is that the granularity of data access is continuing to increase, particularly on the OT side of the house, but also even upstream, so that we can make good and intelligent business decisions based on the data that's available. And so when you're thinking about looking at Industry 4.0 in the context of process manufacturing, you need to also be looking at, okay, so what is the impact of those increased requirements around data granularity and access? And it also means that we should be looking at things like better integration. So how do we shift, from legacy backend systems that were derived from that era of the separate IT and OT systems, and look at how something like a time series platform, and that as a backplane of an architecture, can accommodate the new scale and precision requirements, while also facilitating the transmission of data from one location to another. And we're going to give some examples of folks that are doing this in the real world today. But this open exchange of data is super critical to the smooth operation of any advanced manufacturing process, and it's fundamentally critical to achieving the autonomy that is promised by the whole Industry 4.0 movement. And then lastly, if you're sitting there saying, great, it's all great, and I get it from a conceptual perspective, like, how do you turn this into practice? And so from the folks that we're working with, we're trying to provide that pragmatic assessment and review of when do you take advantage of this. And you might think of this as, timing is everything. And so when we've worked with our existing customers, some of the trigger points where they start looking at this and taking advantage of the concepts of Industry 4.0, looking at the review of their current manufacturing processes, where and if they've already got sensor data that's collected, or maybe where they have blind spots. Looking at developing strategies to ensure that all of the systems that they're working with can handle larger quantities of data than they're currently implemented. And looking at the tools to provide that process automation and real-time analytics. And in particular, some things that you might consider there are external factors that may show up. So for example, control systems. When control systems change over, you're looking at availability of data and potentially additional sensors that you can deploy. This certainly happened in lighting and control systems as those rolled out. The switch from incandescent to LED is an example of that happening in the physical world. Other planned maintenance schedules, as you're doing planned maintenance of activities, this is a place to dig in where you can push the envelope further and faster towards the promise of Industry 4.0. And so, Kelly, with that as sort of the backdrop, I'd love to see what you're seeing with your clients today in that context.
Yeah, no, I mean, you're right, Tim. That, I guess I would take what you just said. And number one thing I took away is there's really not an easy button for this. I mean, it would be nice. You look at the industries that can be characterized in process manufacturing, obviously oil and gas, upstream, downstream, midstream, but also pharma, CPG, biotech, chems, textiles, flooring manufacturers, these types of companies. They're very diverse. They're serving different types of consumers, different types of stakeholders, but they actually all depend on time series data among a lot of other data sets. And I was taking notes, you talked earlier about some of those legacy architectures that are in place. And I think that's one of the things that tends to hold some of these companies back. I mean, it's certainly a lot of the industries are traditional, and there's tremendous amounts of operational excellence and technology in there. But a lot of times, I think on the IT side, what we've seen is that it's a little more, let's just keep the lights on. There's not as much innovation necessarily going on. The innovation is on the shop floor. The innovation's on the drilling rig, less on the IT side. And part of that, I think, I was looking at an HBR review that was published, I think it was last year, 2019. 72% of the participants, and these were large companies across industries, said they have yet to really implement and realize a data culture. And it goes into talking about very few have not created a data-driven organization, data as a true business asset. And I think that we're all, if you're on this talk today, you are actually thinking about those things. And there's a tremendous amount of investment going in. And when I look at those industries within process manufacturing, and to some of your points that you made earlier, I think, I'll try to hit on 3 or 4 of them. Number one is this balancing of traditional legacy architectures, the risk associated with what everybody's doing in the field, whether it's a manufacturing facility, whether it's a drilling rig, a production facility, whatever that is, with making it to some of these modern technologies. And some of these things have been around obviously for decades, and they operate in the most advanced situations in the world. So I think that part of it, the tech is there. We know the tech is there. We talk about this a lot. It's not necessarily a technology problem, but it's this balance between technology, people, process, and I'll even throw in domain and industry, right? Because if you're a CPG company, or you're an oil and gas company, or you're a textile company, your domain is and your industry is going to drive maybe the risk profile or some of the things that I can do. And at a more granular level, your company itself is going to drive what you can do. Just because I'm a super major in oil and gas does not mean that super major number 2 is going to be exactly the same. So I see this, OT as kind of that innovation side. IT is really trying to move to say, how can we leverage some of those time series data sets so that we can be seen as more of an innovator? So that goes in line with what you're talking about with those legacy systems. I think along with that, point 3, maybe, our skill sets are going to continue to have to adjust, continue to have to advance. You talked about Influx being, very, an awesome experience for developers. That's not typically the domain in the IT side. So how do I bring that together to be able to do more in this data-driven posture in process manufacturing? And I think that, and you hit on it earlier, the cloud is coming into play in a big way. You are seeing companies every day essentially say, hey, we can't out Google, we can't out AWS, and we can't out Azure, the big 3 public clouds, right? So remove that burden of infrastructure out of my way. Let me consume Influx in a marketplace environment. Let me consume my other things in a cloud marketplace environment. Make it easy, take that infrastructure out. And when it gets right down to it, I think that regardless of what sector or area within process manufacturing you're in, if I just look at it, going back to what I talked about earlier about working backwards from data consumption, I want information that is as curated as possible. Give it to me as personalized, as believable. Ultimately, it gets down to trust. I want to trust the provenance associated with it, the security associated with it. So curated, contextual, specific to what I need, my business line, my group, make it accessible as well. I don't want to have to wait anymore. We are, can't have these long, 6-month IT projects to get something done. So as frictionless as absolutely possible, and then timely, right? When I want it and highly performing. So I think, to me, those are the kind of themes that continue to repeat as companies across this sector are looking to digitally transform. And, we're kind of stuck. Last thing I'll mention, we did a LinkedIn poll recently, and it was a really simple question. What is the most common issue that you have with data? Number 1 on the list, you could probably guess, is poor data quality. And sometimes it's again, not so much a technology issue, it's a domain issue. It's well over 50%. So I think that when we talk about time series data and data quality, some of those things come into play: the validity, the completeness, the precision, timeliness. So all of those things can be challenges. I think that Influx and what we're doing from an outcome standpoint really help you address. You get your data quality right, your ability to deliver value really flows down from there. So anyway, Tim, that's kind of what we're seeing. Let's switch gears for a minute. Companies, and you talked about this earlier, companies that are making significant strides with time series data and data in general with Influx. Can you go through those for a little bit?
Yeah, for sure. And yeah, this is trying to take this out of the like I'm a terrible conceptual thinker. I was an actual physics major in college, and I did very well in the lab and very poorly in the theory. So let's do some hands-on to kind of reinforce what we're talking about. So Equinor, a little oil and gas company that we work with, has a number of drilling platforms in the North Sea. And what they've done with Influx is we've formed the core of their new data historian that they've rolled out to the drilling platforms. And it's providing the automation and control of all of the drilling platforms that they have. They've deployed InfluxDB open source at the edge to provide that centralized insight to data for the rig operators. However, that's not where the data dies. It lives there, it's accessed there. But one of the things they do is they use a technique called downsampling, which then allows the full resolution data, which they're capturing at relatively high precision. But they're sending off the rig onto back to the corporate headquarters for the IT and analytics to be performed on that downsampled data. And what that does is it relieves some of the pressure in that they can store that high-speed data and provide it to the operational folks, but then they can lower the resolution of that data from, let's say they're doing it at a second basis, and they'll downsample it to, let's say, 30 seconds or a minute, and send that data off for things like, predictive maintenance. How are we doing in terms of the drill head, based on temperature, pressure, the acoustic aspects that Kelly mentioned. And then that data can be fed back to the operator as a valuable insight where they can say, look, we're looking at all the drilling platforms, we're looking at all the substrates that you're drilling through, and we can provide you with some recommendations and best practices to avoid outages around things like, pull the drill head out, let it cool down, maintenance, those sorts of things. Another example that we've got is XTO Energy, which is a subsidiary of Mobile Exxon, also using the open source instance at the edge and trying to simplify their operations through better data analysis. And really what they've done is these folks are drilling and producing unconventional oil and natural gas assets, typically from shale rock, using hydraulic fracturing. And so, the challenge here is whole new data sets being generated, a whole new way to produce these sorts of assets and resources, and they need real-time visibility into what's going on in the drilling process and how the various assets they deployed to extract these materials are functioning. And again, everything from sensor metrics on the wells, the drillers, and the oil fracking pumps are being extracted and utilized in real time. And they've been using InfluxDB for more than a year to assemble this solution. And then two other sort of process manufacturing examples in the mining space, Fortescue in Australia, again, not oil and gas specific, but process manufacturing, where just trying to show examples of, not only sort of replacing the data historian, but using time series data for analytics purposes. So they're really using Influx as the central repository for all the metrics that they gather. And we have very high speed ingestion capabilities, which allows them to deliver on their OT requirements for real-time analysis. And they're doing everything from GPS and location-based things to looking at sensor data from trucks and other mining equipment that are obviously distributed. And it's a similar problem in the oil and gas industry, right, with assets being distributed in various sites, collecting that centrally, and then being able to do the analysis on top. And then last but not least is Tech up in Canada, really focusing on the visibility of their health and machinery, and trying to improve the scalability by streamlining the operations based on the data that they are able to get off of all the equipment that they've deployed. And again, their requirements around the frequency, the gathering of those metrics, and then being able to gain insight and take action is really what drove them to use Influx. And so, Kelly, those 4 quick examples, love to get some from the Hashmap side.
Yeah, no, I appreciate it. Those are great ones. I mean, and you're right. There's not a shortage of use cases in this space at all. When I was thinking about this, I thought about time that we spent recently with a process manufacturer. When we start digging into use cases, again, no shortage of those. This particular process manufacturer, we went through, patterns, data flows, consumption, what's working well, what are the gaps, what's being struggled with today, the various data sources, risk, probably 20, 25 different dimensions. And what came out of that were 15 use cases, everything from, I would say, condition-based monitoring to really personalized real-time alerting and alarming, process traceability, capacity forecasting, quality checks, a number of things. Broadly, 9 out of the 15 use cases with this process manufacturer could be categorized into manufacturing optimization and innovation. So they were really core to the business, and it wasn't just the manufacturing process and the operations team that were interested in these. It was broadly across the organization. They really felt like that data was going to help drive them forward into being able to do things more efficiently for less money. The other 6 out of the 15 were, I could categorize those, I guess, into supply chain, operational efficiency maybe. But there was a common theme. I mean, most of these, if not all, involve time series data sets and decision-making beyond just the operations team. So it's really interesting when you take a look at those. Generally, it's not just 1 or 2 or 3 use cases. It's going to be, hey, we only have a half day here. Let's get this thing kind of sorted out as quickly as possible. But it ends up being a pretty simple equation. Is the way we think about it, speed to impact equals relevance. Today, if it takes me a long time to get to those points where I can actually make decisions around those time series data sets and the other associated data sets that are being enriched with that time series data, that's not a value. Get a foundation established today where you can hit that speed to impact equation for a use case or two. And one of the things that we do in that use case enablement is we try to sort everything out as best we can into that high impact and low risk. Now, not everything falls in that particular quadrant, and you may want to attack something that's not in that quadrant just based on some other a timing or something going on within the business. But if you can, try to fit these initial projects into a 4 to 6 week period of time maximum, get that high impact, get that speed, and establish the relevance. And then you can move on. What aren't we addressing today? What about new applications? Those types of things. So I'd say in general, we're seeing this move to the cloud for new data and analytics products is giving some of that increased business velocity. You're going to have to preserve cash today. There's no doubt about it. I've got to be cost effective. Give me consumption-based pricing. Give me something that I can use where I don't have to go in on a massive capital purchase. Personalized, contextual data, both time series and structured, bring that together in a way that I can take action quicker. And then I think Tim and I have hit on it a number of times, that intense focus on solving real problems as quickly as possible. So that's some thoughts, perspective. Tim, back over to you.
Thanks. And so I want to leave time for Q&A. We only have a few minutes left, but the sort of three last thoughts for the audience that Kelly and I touched on. Number one is time to awesome. We're trying to allow developers to build and assemble solutions focused on solving time series problems prevalent within the world of process manufacturing faster than ever before. And so that's one. And then related to time, being able to act in time. The convergence of OT and IT really means ensuring that the right information, not just data, is available at the right place and the right time for the folks who need it. And this means ensuring operators have what they need while ensuring that information is leveraged in real enough time to drive prescriptive behaviors, which should lead to the autonomy, which fulfills the vision of Industry 4.0. And last but not least, I think you heard from Kelly pretty clearly, timing's everything. Use a practical and pragmatic approach to executing on this vision. And it can be achieved by understanding where to dive in and when to dive in. changes in underlying processes or planned maintenance activities, control system changes, and sort of reviewing use cases around data acquisition and more are really those critical intervention points. And doing so in a discrete time window, 4 to 6 of the ocean, nobody's going to succeed doing that. And so with that, I think we're going to go into Q&A.
Perfect. Thanks, Tim. So we do have time for a question, which I will ask you here, which is how do you align the real-time data with the asset structure, and how do you integrate various data sources to build the digital twins?
Yeah, great question. So a couple of things, and I don't want to dive into like super deep in the weeds technically. One of the things that Influx has done is we went out and looked at how our customers were building applications on top of the platform. And one of the things that we saw is that the asset structures of all of the industrial assets that are out there are typically held and stored in a wide variety of relationships. And what this meant was that the developer then would have to build an application, tapped in queries specific for the relational source where that asset data resided, and then 2, do a separate query to Influx to then pull in the time series data and then join them within their application. And one of the things that we set out to resolve in this whole notion of time to awesome is how can I actually allow the developer to write a single query that will access both data sources and combine them without having to write like actual application logic. And so our query language that we developed called Flux, Flux is the query language, has the ability to tap into a dozen or more non-time series sources in a way that developers would find very friendly, and pull that data into context while working with the time series data and join them together without having to go out to a compiler and writing specific code. And so that allows you to provide an integrated set of the data itself. And then the next question you're asking is about how do you use that upstream to things like building a digital twin. And for those that aren't familiar with that concept, the idea is if you have a physical device, you have essentially a digital replica of that that you can use to do testing, evaluation, and more. And so really honestly, gathering the data and being able to integrate it is the first step towards that sort of modeling and that sort of learning environment, and then the automation that comes from that next.
Great. Thank you so much, Tim and Kelly, for the interesting and informative webinar. For those in the audience, if you want to listen again, this webinar will be available on demand shortly. And finally, thank you wherever you are for taking the time to listen in. We look forward to having you on the next session starting in just a few minutes. Enjoy your day. Thanks again, Tim and Kelly.